So today's session, measuring performance of natural technologies, will highlight some case studies, the results and methodologies to measure the performance and validation of the energy of various natural system installations. So today I'll be joined by our presenters, Frank Davis, the Senior Director of Refrigeration and Sustainability with Grocery Outlet, Safdar Chaudhry, the Senior Engineer Manager for ADM Associates, and Kathleen Ave, the Senior Climate and Ecosystem Strategist, Customer and Grid Strategy for SMUD. And now I'm going to hand things over to Kathleen to start us off and give it a little bit of background about the Sacramento Municipal Utility District. Go ahead, Kathleen.
Thank you very much, Danielle. Thanks everyone for being here, and absolutely to NASRC for your leadership in this area and for being a real integral partner in this particular project that I'm going to describe. I also want to mention my colleague Ryan Hammond is here as well, who was a hand-in-hand partner in the development of this program. So SMUD, for those of you who don't live here in Sacramento County, we are the Sacramento Municipal Utility District. We are a large publicly owned electric utility, although we serve basically Sacramento County, so not a big utility compared to a lot of the IOUs that are out there. We have a publicly elected board of directors, which is one of the benefits of our MOU, or POU, sorry, because they get very clear feedback from our community and are really engaged in developing policy for the organization. The most important of which recently has been the adoption of a zero carbon goal, zero carbon by 2030 for our electric service. And that is a very ambitious plan that has shaped a lot of organizational change within SMUD over the last year or so. Next slide, please. And this is just a really quick overview. There are multiple elements to our pathway of getting to zero carbon: repurposing our natural gas-fired power plants, investing in proven clean technology, but also new technology and new business models for achieving that goal. And all along the way, maximizing benefits to our community. And I think that this program really kind of fits into that category, the last two categories, in that it's something new for a utility and also with big benefit to the community. Next slide, please. This is an outdated slide for California's climate strategy, but it was present and it was active at the time that this program started. And so I like to highlight it because, you know, working in natural refrigerants is not a typical utility thing. The three pillars on the left-hand side of the slide, you know, renewable electricity, electric vehicles, and energy efficiency are really the places where a lot of people expect utilities to be acting. But reducing short-lived climate pollutants was a huge opportunity and really compatible with a lot of the work that we were already doing with our commercial customers. And that's really what led to the development of this program. Next slide. And so we launched it at another NASRC workshop that was hosted at SMUD back in 2017. It's kind of hard to believe. And it took a few years before we got uptake. And the objective here was to help address the fact that at the time, high GWP refrigerants were projected to result in emissions of over 1 million metric tons in Sacramento alone by 2050. So here it's an example of these are not necessarily SMUD emissions, but are really potential large growth in our community and something that we could pay attention to. So Ryan and I, working together, built on the custom incentive and savings by design programs and created an additional incentive for direct greenhouse gas emissions reductions from new or retrofitted low GWP systems. Next slide, please. And the objectives were to basically help our customers really create a cost-effective pathway for natural refrigerants, and you know, position SMUD to leverage future state funding, which we at the time believed was coming, and support that transition to a carbon metric for program evaluation, not just looking at KW and KWH, but thinking about our customers' greenhouse gas emissions as well. Next slide, please. And the benefits, which most of you dialing in probably are looking for, is ending the cycle of upgrades and retrofits as refrigerants are phased out, really assisting with the incremental cost of new equipment. And this was really a big one from our customers' perspective. So the delta between a natural refrigerant system and a conventional system. And then, helping to support this emerging technology, and then creating in our local service area a network of manufacturers, engineers, technicians, kind of an ecosystem of people who can support these kinds of projects. Next slide, please. So this is information about the incentive structure and the types of programs that are eligible. We did require 3 years of system monitoring and paid for the installation and integration of monitoring equipment, as well as the measurement and validation work that Safdar will talk about. And the incentives, as I mentioned before, were based on kilowatt hour and kW incentives, but also a $25 per metric ton emissions reduction from refrigerants. And the total incentive for the emissions reductions was 30% of the project cost, or $150,000 total. And we have also offered a small benefit for projects that were located in disadvantaged communities and implemented by small or medium-sized businesses. Next slide. So we came at that, setting that price or the incentive value a couple different ways based on our current energy incentives, and also looking at California's greenhouse gas allowance price floor for 15 years based on some annual escalation. And anyway, we landed in both places, in both directions, at $25 a metric ton. Next slide. So I wanted to note, importantly, this is not actually a low GWP program. One of my older slides still has that, but we understand that the actual composition and impact of HFOs is not currently well studied or understood yet. And there are concerns that are emerging about byproducts and also potential restriction as a PFAS forever chemical. So given that we have a track record in this space of potential for unintended consequences, right? We have the example of the ozone layer, the problems with the ozone layer, being replaced by chemicals that caused a more global warming, and concerns about future aquatic degradation. So we decided right when we were about to launch the program to make it support natural refrigerants only. Next slide, please. So as I mentioned, we launched in 2017. It took a while because of the high system cost and what we recognize are very slim margins in the supermarket industry. We did get proposals from processors and stores around the state, actually, and I'll come back to that maybe at the end. But we have just a boundary of Sacramento County for our service territory, so we had to say no to those folks. And also because retrofits to natural systems really require an entire new system, and it's very disruptive to store operations. So these are not projects that people enter into, quickly, and certainly not just based on a utility incentive. But we did have our partners, Grocery Outlet and Raley's, that enrolled. And because we had 2 supermarket chains, we had the opportunity to create a kind of unique research plan that would establish control stores for each of the chains, as well as the experimental store with the new system. We did get $125,000 from the American Public Power Association as part of their DEED program. And we have done 2 years now of complete monitoring for systems, and got an award for this program in June. Next slide, please. Total spending here is broken down for each of the recipients, showing the incentive through the Savings by Design program, as well as the Natural Refrigerant Incentive Program. And so the total incentives that that these customers received was just under $300,000. And we spent about that much on M&V, but that included both the monitoring equipment and the installation of it, as well as technical support and all the technical report writing. And so between that and the dollars that we subcontracted with NASRC for training and outreach and our own staff time, it's a pretty modest investment from a utility to better understand these really significant potential benefits. Next slide. And I guess that's it from my presentation. But before I close, I wanted to suggest to any of you on the line who are interested in working with your local electric utility, whether it is a corporate entity or publicly owned, it's important to remember utilities are rigidly hierarchical organizations, even the most progressive of them. And so I would suggest that it is really important for you to reach out to board members, to executives, if you would like to see a similar incentive type program in your community. There is a lot of synergy between the work that account managers within utilities are already doing, like Ryan, with commercial customers. And so creating a program like this that kind of works in tandem, it's not a huge investment, and it can really add some important value to society to help address these short-lived climate pollutants. So with that, I will turn it back to you, Danielle.
Thank you so much, Kathleen. Next, we'll hear from Frank, who's going to share with us perspective from retailer, from his perspective on the system and working through this program.
Okay, thanks. Good afternoon, everybody. First slide, I'll just give a brief overview. Grocery outlet and what was the driving factors to do this project. So first, grocery outlet is publicly owned as of 2019. I know I didn't update the slide. It's about 430 stores today in 8 states, 10 more stores, new stores by the end of the year. So we have about 440 by the end of the year. And the goal is to 10% year-over-year growth on the base count. So they are growing pretty fast. Several other states in the mix as well with this growth expansion. So what was the driving factor for this project mainly was when the discussions began for this project, it was back in 2018. So, Grocery Outlet was still looking at what do we do for CARB, to meet the 2022 regulation. So that was the main reason, to install this technology. It'll be under 150 GWP. We can gather data, determine what direction we want to go on future stores. And, they knew the growth plan at that time, knew we're going into different states. So as we're all aware of on this call, I mean, things have changed pretty dramatically throughout the United States. There'll be more states probably adopting the CARB regs or something similar. So that was the main reason for the whole project. Next slide, please. So we installed a CO2 transcritical system with an adiabatic condenser. The HVAC unit, we stayed with the main air handler and a condensing unit with 448. We did not do CO2 on the main air handler. It was the cost, although we did receive rebates and from SMUD and the grant, which helped tremendously push the project, just still had to stay below a certain threshold to make it the ROI pan out. So that was the system. Second, the overview of the project. Like I said, incentives played a huge role. We probably wouldn't have did the project at this time if we didn't have those incentives. Was partnering with SMUD and the NASRC and Danielle and team. They made it really easy to capture these rebates. Importantly, plan our CapEx. So once we got the cost up front, what we were going to receive, which was almost $220K, which is about the additional cost of this technology versus our typical 448, we'll call prototype DX rack. So went to CFO, C-suite, it was an easy conversation. A little bit about the project, opened January 15th, 2020. We, as stated before, we had the reduction of GWP, met carbon requirements, met our weighted average, kind of reduced that a little bit. And like I said, educated the company on the new technology and determined direction moving forward. Are we going to do CO2, micro distributive? Are we going to do single systems? You know, what direction we want to go. So the challenges, same as they are today, I think. However, better in some regions, but installation, startup, techs being able to work on it. It's getting better. You know, some parts like Southern California, there's a lot of these systems in circulation. So, you know, the techs are really getting more familiarized with them. Still have some smaller regions where it's hard to find a refrigeration rack technician, let alone, you know, a CO2 mechanic. So that's a challenge. Maintenance the first year, there was a lot of service calls, particularly with the oil system. They lost some product, but how grocery outlet's structured, we provide the assets, the corporate office, we split maintenance cost, we split product, you know, sales, product loss, we would split. So even though we absorbed a lot of that cost for service calls during the first year, the operator pays for the labor, you know, to pull the product. They split cost on the product. So I think that was the biggest challenge. Today it's running similar to one of our DX stores. Next slide, please. And then future projects, yeah, we'd like to see, like I said, the incentives were super easy to obtain. And I know there's a lot of people on this call where we don't have deep teams, and we don't have a lot of time to spend tracking these rebates. The goal is to get the projects going and get the store open. So they made it super easy. We'd like to see more of these moving forward. We'd like to try it on remodels if the you know, if the ROI is there. And then the question, are we going to move forward with CO2? Yes, that is our specification currently in the California region. We are looking at, do we expand to other regions? You know, more to come on that, but today it is our spec for California. We'll continue to look for rebate opportunities. And again, if you're a retailer looking at trying to capture these rebates, I encourage it. Very easy to do.
Thanks so much, Frank.
No problem.
Next, we'll hear from Safdar to give us an overview of the M&V study that was completed along with the results of the study.
Good afternoon, everyone. My name is Safdar Chaudhry. I work with ADM Associates. This particular study was sponsored by SMUD. ADM Associates was the prime contractor, but EPRI also helped us with the analysis and report writing. So first of all, a little bit introductions of the methodology. So the IP MVP option B was used, where we monitored the components associated with the systems. Basically, there were 4 stores involved in this study. 2 grocery outlets store chain participated in the study, grocery outlet, and then Raley's and Bel Air. We selected 2 stores from each. One of them was the comparison store, and the other one was the treatment store. Comparison store for the grocery outlet was the one which was located in the parked area, and the treatment store was in East Sacramento. So similarly, for Raley's and Bel Air, we had Bel Air store located at Arco Boulevard, and then the Raley's store, which was the treatment store, was located at Freeport Boulevard. So each of these paired sets of the stores, as I mentioned, had a comparison store as well as a treatment store. So both of the comparison stores were HFC refrigerant, using the HFC refrigerant systems, R404A, and the grocery outlet and the Rayleigh store, which were treatment store, they were actually quite different, because the grocery outlet treatment store was completely using a CO2 refrigeration system, but the Rayleigh's was a hybrid system where it was using ammonia as the refrigerant, but the heat transfer fluid was the CO2. So long-term monitoring was performed starting from July of 2020 until March of 2022. The monitoring actually continued until yesterday. We just removed the data loggers yesterday, but we had to stop the monitoring in March, not the monitoring, the data collection in March to start doing our analysis and writing the report. But we do have another 6 months worth of data for these stores. Next slide, please. So this is the high-level summary of the grocery outlet stores. As you can see, the floor area is pretty similar for both comparison store and treatment store, about 24,000. The pocket area store is a little bit smaller, about maybe 3%. The system type, as I already mentioned, for the comparison store was HFC system, but the treatment store had the transcritical CO2 booster system. The condenser type was air-cooled for the comparison store, whereas the treatment store was using adiabatic. The refrigerant was R404A for the comparison store and R744 for the treatment store. The refrigerant global warming potential is almost 4,000 compared to the treatment store where it is 1 for the CO2 system. The refrigerant charge was 600 pounds in the comparison store and 420 pounds in the treatment store. The vintage was 2013 for the comparison store and 2020, which is about 2 years old, approximately, for the treatment store. Next slide, please. So here is a little bit more information about the system. This is the comparison store for the grocery outlet. It is using the conventional refrigeration system, R404A, as I mentioned earlier. There are 23 refrigeration cases of varying sizes and temperatures, and the total of 241,000 BTUs, the capacity, the load cooling load capacity for the system. There is a total of 41.5 horsepower compressors, to 10 horsepower to 7.5 horsepower, and a 6.5 horsepower compressors serving the system. There are also 5 air-cooled condensers, the total capacity of which is 33.8 MVH. Next, please. So this is the grocery outlet treatment store. The store refrigeration system is using CO2, R744 as a refrigerant. The refrigeration system is driven by 4 compressors, 2 of which are 20 horsepower, 1 3.5, another one 2 horsepower, serving various temperatures. The refrigeration total sum to the total of 404 MBH. The compressor's total capacity is 477 MBH, and the condenser capacity is about 547 MBH. Next, please. Here are the results of this evaluation. The CO2 booster adiabatic R74 44 system was found to be superior than HFC conventional system in terms of efficiency, energy cost, and CO2 equivalent emissions effects. This is true for the grocery outlet system. The Rayleighs and Bell areas is a little bit different story. This R74-based refrigeration system used 27% less energy compared to the conventional HFC system, resulting in 23% reduction in energy cost based on the current electric rate applicable to this utility, this facility. The installation and equipment costs for the CO2 booster system are approximately 24% higher than the comparable conventional HFC system. The operating costs of R744 is estimated to be lower than the HFC system. Next slide, please. The R744-based refrigeration system reduced the CO2 emission by 27% compared to its counterpart HFC conventional system. There was no leakage reported for both stores. This is very rare. If there was a leakage in the store, the natural system eventually would have been even more, which is a 93% reduction if we use the EPA's national average for the leakage. Next slide, please. So this is a high-level summary for the Rayleighs and Bel stores. So as you can see, this is about 3 times a bigger store than the grocery outlet. But when we compare Bel with the Rayleighs, they're approximately the same size. The system type is 2-stage direct drive, this is for the comparison store. The treatment store, 2-stage direct drive CO2 liquid overfeed. The refrigerant is R404, just like the grocery outlet for the comparison system, but for the treatment system, it is the ammonia, as I mentioned earlier, R717, and the CO2 system is used as a circulating fluid. Refrigerant global warming potential is again 3,922 compared to ammonia, which is 0 and 1 for the CO2. The refrigerant charge is 2,300 pounds for the comparison system and 140 pounds for the ammonia and 3,200 pounds for the CO2. Vintage, the comparison store was built in 2006, whereas the Rayleighs has the same vintage as the grocery outlet treatment store. This is 2020. Next slide, please. So here is the overview of each of the system. So this is the comparison system for the Bel Air. The comparison store has conventional compressors using R404 refrigerant, just like the grocery outlet comparison system. 275 horsepower, 250 horsepower, and 220 horsepower compressors are being used to serve the system, which makes the total 290 horsepower. And the total cooling capacity is 284.4 mph, serving various temperatures. There are evaporatively cooled condensers of 2,697 mph nominal capacity. Next slide, please. So here is an overview of the treatment store, which is Rayleighs, located at Freeport Boulevard. The treatment store uses ammonia as a refrigeration working fluid and the CO2 as the circulating fluid. It's a hybrid system. The disadvantage of the system is that the additional heat exchangers are required, which create performance loss and increased cost. issues. The refrigeration system is driven by 6 compressors, 4 of which are 50 horsepower, 2 are 15 horsepower, serving various temperatures. The compressor total capacity is 2,215 MVH. Next slide, please. So here are the results for the Rayleigh's. The Rayleigh's refrigeration system was found inferior to HFC system. This is opposite to the grocery outlet system. And the reason which I mentioned earlier is because the inefficiencies due to the heat exchanger. The Rayleigh's ammonia CO2 natural refrigeration system used 18% more energy than the comparable Valaire's conventional HFC based system. The increase in refrigeration energy use at Rayleigh's ammonia CO2 is due to the heat transfer inefficiencies compared to a single fluid system, which I mentioned before. The installation and equipment cost of Rayleigh's ammonia CO2 system are approximately 18% higher than the comparable Valaire HFC-based system. Next slide, please. The Valaire operation team reported a leakage of 14%, and Rayleigh's reported significant dissipation of refrigerant charge during first year of operation. Although the emission associated with the energy use were higher, the low GWP of Rayleigh's natural refrigerant enabled it to maintain lower overall emission of it. So although there was a leakage, but because of the trade-off between CO2 and the HFC refrigerants, the emissions were 74% less for the system. Next slide, please. So some of the conclusions of the study: natural refrigerant system have a positive environment impact due to the reduced global warming potential of the refrigerants. The energy impact of natural refrigeration in the pair of grocery outlets was as shown to be favorable, while the energy impact of the natural refrigerants in the paired Rayleigh's and Valaire stores showed an increase in the energy use. More rigorous calculations of refrigeration technology is needed with the large samples. So since this was a very small sample, so I think we cannot make a positive conclusion based on just one case. So I think there will be more studies needed. Similar studies will be needed to have more confidence in the results. Rayleigh's interacts with multiple other subsystems. So if you look at the overall system, for example, how much water it is saving, and the heat rejection system, and so forth. So it may still be show some positive impacts. Long-term maintenance data was not possible within this study period because it was only less than 2 years. And there are approximately 4,000 grocery stores in California, with approximately 200 stores within the SMUD service territory. So there is a great potential for this technology. Next slide, please. Thanks for listening.
Great. Thank you so much, Safdar, for reviewing the results of the case study. And I will mention that NASRC will be releasing a case study that we've partnered with SMUD and ADM to put together that will be on the grocery outlet site that we'll be releasing here in the near term. And then to your point, Safdar, about looking at Rayleigh's and the entire utility picture, including water, natural gas, and some of the other benefits of the system design. There is a study being commissioned by Southern California Edison, SCE, to look at that and compare not only the performance of that ammonia store, but a new store built around the same time that uses a HFO blend. So it'll be very interesting to look at the results from each of those studies.
Great, thank you.
Great to have all the data. Great. So we now have some time for Q&A. So if you have a question, please go ahead and use the Q&A section, enter your question in there. So the first question is also a compliment. Impressive results for CO2 in Sacramento. Congratulations, Frank and team. Was the baseline grocery outlet store evaporatively cooled or dry condenser?
That's a air-cooled condenser. Good question.
That's right. And Frank, when Grocery Outlet was considering that system design, you looked at a transcritical CO2 without the adiabatic condenser. Can you speak to the reasons why the adiabatic was chosen?
Just trying to capture the better energy savings, which there's a lot of data on that now. And when I was speaking about the owner operator, they pay the utility bill, so it's a big deal, especially if they're coming from another store and you hand them a new store with more expensive. It doesn't go over well. So energy was the driving factor for that.
Great. So, and also a question for you, Frank. You mentioned looking at other system architectures, even though CO2 is going to be standard for new stores. What other kind of system architectures are you looking at for existing stores?
So we've did in California 4 propane micro distributive, 1 out of state with the same technology. So still looking at that. There's some opportunities for improvement there. We looked at single systems. Does that work? There's some interest in A2Ls that are hitting the market that may be a solution for us. So we're looking at those 3 options.
Great. And then you also mentioned, Frank, a challenge around the service workforce, not only just for the stores existing out there, but for training on CO2. And I'll put a quick plug in to say that we're going to be organizing together with SMUD and for this particular grocery outlet site, a training that will be a combined classroom and hands-on training put on by Hill Phoenix, the partner OEM in this project. So looking forward to that. You can find more information on our website. But my question for you, Frank, is, what do you think is the main challenge in, helping the service workforce get educated on these system types?
Well, I definitely think it's training. I don't think there's enough of it. And so to your point, we'll do that training this year. We've already have one scheduled in Southern California in January. I guess we're try to overwhelm the training this next year, do as many as we possibly can. And then, just encourage. What happens a lot of times if you do train, and it seems like there's only 1 or 2 technicians that really know how to work on it, or they all get the training and then they send the top guy, and that guy's the only one that knows how to work on it. So just trying to collaborate with them and let them know that, hey, this is our spec moving forward. So it's benefit to you to get more technicians involved. It could lead to more stores potentially.
Great. A question here for Kathleen. Do you know of any other utilities that are following SMUD's wonderful example?
Oh, that's a great question. I wish I could say, yeah, there's a long list, but we, like I mentioned, we did get inquiries from food processors and others in other parts of the state. And when we did that, we did make attempts to reach out to like reps at PG&E, or I think Southern California Edison was the other one. But unfortunately, at this point, I don't know of any others. Ryan and I have actually had conversations with folks in Vermont, I think, and a few other places. I mean, anytime anybody has interest in talking about it and trying to start another program, we're very supportive and happy to confer. But no, to my knowledge, there are still no other active utility programs.
It is a great question, and we've been presenting together for a long time, Kathleen, and we continue to say that SMUD is the only utility that offers these types of incentives for the GWP or GHG benefits of the GWP. Other utilities are exploring this, and certainly there's some steps forward being made in California. We'll be talking about those more in our workshop on Friday, and some of the steps that are necessary, I guess, to get there. What advice would you offer to utilities that are just starting to look at this? You know, where do they begin?
Well, I mean, I think they begin with their customers, you know, reaching out to folks like Frank and Rayleigh's, Ed Esberg, and finding out where they are in their process of evaluating, you know, good opportunities for greenhouse gas emissions reduction. And then understanding, you know, working internally with their own program people to figure out, you know, what existing programs do we have that we can leverage so we don't have to create a lot of new overhead, but do this fairly simply and effectively. So, but yeah, no, I think it really starts with the community and, you know, finding willing partners. And it proved a little harder. It took longer than we expected in Sacramento, but you know, that it's good to hold out for some participants when they're ready, and then you know, we're doing what we can now. We don't know if we're going to be able to extend this program. I see there's one more question about any more stores. Not yet. Now that we are in the final stages of this evaluation, we'll be having an internal discussion again about how we can proliferate it, and also be looking at what the state's incentives are to see how we can marry up with those and make an even more compelling case for our customers. So we'll see, that's TBD.
Great, maybe they can start by giving you a call too.
Sure.
Yeah. Well, the data piece is so important too. And so, you know, I thank you for being transparent about the cost of that data, because it was a significant part of the program, but it's so important because for other utilities to look into this and begin, they do need data. And so it's great that you're able to share that. There's a couple questions here that kind of speak to the baseline. And I know back in 2020, the baseline was very different then, because you still could build a store using 404. And so, you know, one question is around comparing CO2 to ammonia. And did you ever look at making a comparison between the two sites? And then the other question here is, you know, how did you make the decision about the store comparison? And maybe Safdar, this is a question for you as well, because now in California, you can't build anything but a store with less than 150 GWP.
Do you want to take that, Safdar? I mean, I'll just jump in. We haven't really decided how we will handle that going forward, because like I said, with the focus now on our zero carbon plan, you know, we don't know that we're actually going to be able to continue this, but I agree that's absolutely something we would have to figure out going forward. You know, how would we do that comparison? Ryan, I don't know if you have anything else that you'd want to add there. Okay.
I don't have any, yeah.
Great. Another question came about the baseline stores, or I think you were calling them the comparison stores, and whether or not they received any kind of retro commissioning prior to, because the vintage on both of those was significantly older than the treatment stores? Do you know if they were retro commissioned? Maybe Frank, that's a question for you about the.
Yeah, they were not. So that's a good question. They were running from an original startup, and so there are some differences: air cooled condenser, mechanical expansion valve versus electronic would be probably the two notable benefits of CO2.
What about the number of open versus reach-in cases? Do you recall, Frank, if
that I don't recall?
Okay, it'd be interesting question to answer too. Great. And so one other thing I'll put a plug in for is just that the CARB FRIP program, the F-gas reduction program that funded a number of sites in California, is also commissioning an M&V study that will compare different types of natural systems to one another. So more data to come. Exciting to see. Do you know, I don't know if Safdar, you would know the answer to this, but if the CO2 transcritical system, grocery outlet system, did it spend any time in supercritical mode? And if so, how much time?
I do not have that information. Sorry.
Yeah.
No problem.
Yeah, I don't know either, but obviously all summer, anything above 87 degrees would have been in, well, actually, transcriticals.
Yeah, it's a warm climate in Sacramento. Great. So I guess, Kathleen, if you were to offer this program again in the future, are there any changes that come to mind, things that you would do differently the next time around?
Well, I think we would position it, I think, a little bit differently with our management. I think we would let them know that we would expect longer lead times, that these projects, especially right now when apparently supply chain issues are impacting the delivery of materials, this is the kind of work that takes a lot of patience. And so I credit our management for being willing to keep the incentive out there for as long as they did, when we weren't getting uptake. I think that we would probably try to do, we just didn't have the resources to do this, but it would have been great to have done more kind of community outreach to local technicians and service companies and others, to just kind of do more education about the options, and just kind of seed a little bit more of that, and maybe get a few more projects in the door when we were still active. That's what I think of off the top of my head. Ryan, do you have any other things that you would add? I would love to have offered an even bigger incentive. Okay, this is me speaking personally, because I know how important these incremental costs are, and we are in a situation where we need to move quickly. And so yeah, I know that's a really big factor from our customers' perspective, but I would not get support from my management on that one. I don't think.
Yeah. Yeah, it's interesting. Like I would share with customers, it ended up being a really lucrative incentive on paper, 150, up to 150,000, and that value was achieved pretty quickly with the GHG emissions, but it was still a bit soft compared to what the cost of the systems were. And I tried to let customers know, it helps take the edge off the experience, but it would have been nice to have it be stronger. But I would like to highlight too, I think it's a really excellent, well-designed program, and its biggest focus was on honoring natural refrigerants. So there's a real glimmer and a real glow and a real attraction to low GWP, but folks truly heartfelt need to keep in mind, low GWP doesn't translate to a clean refrigerant, if you will. And what I mean by that is like what Kathleen had in her slide about the indication about HFOs being pretty rough on the environment. Like, yes, they answer one piece of the puzzle, low GWP, which is perfect. But there's also the Department of Toxicology would also be very interested in the other component of this. And we definitely don't want to repeat what's been done in the past with CFCs, which were chewing up the ozone. People got nervous, brought out HCFCs, which things started getting a little roasty, a little warmed up. Now people are starting to react again and focus just on low GWP instead of a holistic approach. And I hope that's okay to mention. But it's what we need to do. And saying this as an engineer, I'll say this. I mean, in engineering school, they teach you to look inside the box only. And they teach you to look at the squiggly line going in and the squiggly line going out. Very little holistic attention to the earth around us, you know? And it's much, much easier. It's so simple to look inside that box, much more difficult to look outside the box. But that is where we need to go, is outside the box. The one thing I'd like to highlight too, I know there's an emphasis of, you know, utility programs being interested in developing an incentive program. The California Air Resources Board also worked on I think they developed an incentive program. But what's interesting is not only can utilities reference the program that we've created, government agencies can reference that program that we created. And what I mean by that, it's always very, very difficult to develop a utility incentive program or any incentive program. And what I mean by that is you have to go through and be very mindful of what you're trying to convey, what you're trying to implement, and create a structure that someone can successfully participate in that, and it makes sense for everyone. So that the biggest hurdle has been accomplished with this incentive program. Those documents are publicly available. We actually encourage people to adopt that and improve upon it, make it better. But that, I can't tell you how much work that would save any entity who wants to implement an incentive program. So I know it's a little bit of a digression there, but
I appreciate that holistic thinking and long-term thinking, right? We have an opportunity to do that. And so it's wonderful.
Very conscious. Very, very conscious effort on Kathleen's and my part early on when we released the program. I think it was like, I wanted to throw out a week or 2 weeks before we were going to release the program, and we were shared with this information about HFOs and the potential harmful side effects, like Kathleen pointed out, the TFAs, etc. And we switched it from low GWP to focus on natural refrigerants because we did not want to fund those unknowns. We weren't sure what was going on. Naturals were a sure case, but the low GWPs was another. HFOs was another one. Okay, anyways, here we go.
No, thank you. Thanks, Ryan, for giving that context. It's really important. There is a question about kind of, you know, because of the CARB regulations, doesn't it mean there's more of a need more than ever for a program like SMUDS? And I think one thing folks may not understand is, you know, when SMUD put together the budget for this program, it doesn't come from your typical incentive sources, right, that are kind of allocated to you to go, you know, approved for the purpose of what is, you know, reducing energy, right, KWH therms. This was kind of a different bucket of money, if you will. It was, I don't know, paying out of your own pocket. I don't know what's the right term, but it's one of the reasons why other utility programs couldn't move forward, is because they're kind of stuck on this needing that incentive metric to be realigned. And so, yes, I think there's more need now more than ever for programs like yours, but you need those incentive metrics to be there, right? Looking at the shifting from the inside the box energy to the whole picture of emissions, right? Can you speak to that a little bit?
Kathleen, or myself, or Kathleen?
Either one.
I can speak somewhat to it. Like, you're totally correct about that KWH, KW benefit to the utility, the way they are able to justify paying incentives for reducing energy is that it saves the utility and helps them manage grid demand, etc. But what's interesting about the natural refrigerant incentive money is that was actually a gift SMUD essentially to the world at large, because that refrigerant emission goes out from our territory, you know, but goes out to the rest of the world. There's no direct benefit to the utility per se, but it's a gift to the world at large. Yeah, so it's kind of an expensive experience from that perspective, because you don't see the immediate return, but the hopefully our what is it, our generations to precede us or whatever are thanking us later on, which I'm sure they will. But you know, and speaking to,
I was going to add to that, you know, SMUD also operates a free shade tree program. It's one of the only utilities in the country that operates that. We've had it for decades now. That also now, that always used to be, the whole program was developed to provide shade, to reduce, you know, electricity use and cooling load. And that program also has been evolved to have a carbon focus. So now we give away evergreen trees in addition to deciduous trees, and people can get more than one tree, and that's for the carbon sequestration benefits. So I feel like it's another example of a place where we're evolving as an institution to recognize what are the big societal factors that should drive business decisions and personal decisions. And this is kind of part of that. We're on a continuum.
And a great entity to help support incentives such as this would be governmental agencies to help finance, like, or, you know, support. Yeah. So anyways.
Great. Well, we'll hear more about some of those funding mechanisms in our session tomorrow on funding for natural refrigerants, and then also a continuation of this conversation on utility metrics in our workshop on Friday. So I want to thank all of our presenters today for sharing this information, for being on the bleeding edge in some cases. Whether it's data or first installations, and, you know, sharing the information is so valuable. So thank you.
Thank you.